object is moving as shown in this diagram, we can use these three equations for it to calculate whatever we are asked to calculate. But take note that the object must be moving with a uniform acceleration. By uniform acceleration, we mean the velocity of the object keeps increasing by equal amount in equal intervals of time. The velocity of the object keeps increasing by equal amount in equal intervals of time. In case 2, we have an object thrown as shown in the diagram here. For an object thrown in this manner, that is, the object is thrown vertically upward, stops at the highest point, and then starts coming down. A is equals to minus G. We take our A to be minus G when the object is going up. We take A to be equal to plus G when the object is coming down. And our S, instead of our S, we will use H. This is because vertical distance is covered. We can therefore write equation for when the object is coming down using the three equations of motion that we already know for an object in a straight line on the ground. When the object is coming down, don't forget, we take our G to be positive, and so we have V is equals to U plus GT. Our A is now G, which is the acceleration due to gravity. Also, V square is equals to U square plus 2GH. And the third one, H is equals to UT plus half GT square. Daddy. When the object is going up, we use the equation V is equals to U minus GT. Don't forget, when the object is going up, we use our G is negative. We take our G to be negative. So the first equation gives us V is equals to U minus GT. The second equation, when the object is going up, is V squared is equals to U squared minus 2GH. And the third equation is H is equals to UT minus half 1 over 2. H is equals to UT minus 1 over 2, 1 divided by 2, GT square. So for any object thrown in this manner, it will be thrown with a particular initial velocity. By the time it gets to the highest point, the final velocity at the highest point is 0, which shows the first path of the journey, that is when it is going up. The second part of the journey of the object, that is when it is coming down, our U is taken to be 0, and the velocity keeps increasing until it gets to a particular value v just before the object drops to the ground. Case 3, that is when we have an object thrown as shown in the diagram here. That is, the object is thrown at an angle to the horizontal. For an object thrown at an angle theta, to the horizontal, we can write the equations of motion along the vertical v and along the horizontal h. This is because the object is performing two motion simultaneously, and that is the reason why the object is moving up and at the same time moving away from where it was thrown. For the vertical motion, when the object is coming down or going up, we will use v is equals to u plus gt. For equation 2, we will use v square vertical is equals to u square vertical plus 2g vertical then h vertical. Also, for equation 3, our h, which is the vertical distance covered, is equals to h vertical u vertical plus half g vertical then t squared. So when we want to calculate anything that has to do with the vertical, we use the 3 equations written that has to do with the vertical motion of the object. But when we have to calculate anything that has to do with the horizontal motion of the object, that is when the object is going up or coming down, we use v vertical u vertical. In this case it's going to be horizontal. In this case it will be horizontal. So hv horizontal is equals to u horizontal plus g horizontal t. Also, for equation 2, v horizontal is equals to h horizontal plus 2g horizontal and h horizontal. Also, for our h horizontal, which is the horizontal distance, horizontal height covered, is equals to u horizontal t plus g horizontal half g horizontal t squared. If you are able to separate the equations of motion you will use for your calculation as explained this way, any question under motion in a straight line or an object thrown vertically upwards or an object thrown at an angle to the horizontal, which is projectile, will be a walkover for you. Thank you for the class. Hope to see you in the next class. Bye.